our first talker is Aki Pehkonen from Nortal, Finland, and our second talker is Priit Liivak from Nortal, Estonia. A little bit about our talkers. Aki is, as I mentioned, one of Nortal's leaders. He's a lead architect. He has had about 20 years of experience in the IT field, in various architecture leadership roles, and of course, with that, amazing baggage of knowledge. Here is today just a little bit of that we're going to share with you, and hopefully you guys will enjoy these two talks. So on that note, I'd like to give it over to Aki. Take it away.
Thank you, Marko. Can you all see my screen now? So my name is Aki, and I'm going to talk today about modern discoverability. And while I'll be doing the presentation part, I have my friend Oupi Tuutila here with me, and he's going to answer any questions you may have during the presentation. So please find the question and answers section in the Teams chat, and you are free to answer any questions. And then after the talk, we can discuss those in a little bit more detail. All right. So I want to talk about this concept of discoverability. So let me first set the scene and give you an introduction why this is really important topic and what it is actually, what is discoverability and how you can use that to, in your business. Then I'm going to talk a little bit about guiding principles that I feel that are the most important ones, and then give you a little bit of a demo that we've been doing here at Nortal, and then putting it all together and give some key takeaways, and then maybe we can discuss about certain things in the project. So my presentation is largely aimed for bigger enterprises that they usually they have a long history behind, and usually what I've seen in the past is that the role of IT in the organizations has changed a lot, and while it has been more like a supporting role, maybe used in as a back office thing, it has become more like tech-led differentiation or tech at core, and the meaning of technology in business has become much more important than before. And really how it has been usually that IT is more like a cost center. I believe it has become more a profit center, and the inability to execute can mean loss for the company. And there's clearly a sustainability gap between the opportunities in a business and then traditional IT ability to deliver, and that's the gap that expose your business to competition. And the biggest challenge in an enterprise environment today is that they are getting extremely complex. There's multiple stakeholders, and they are sort of multi-sided platforms that you have customers, partners, employees. You may have API providers, third-party providers, and you need to orchestrate all of this to create this system. And it's, in a way, it's a complex adaptive system that in many ways there's no anyone who can actually explain the system thoroughly and explain what are the components in a system. And usually these are really a lot of manual processes and manually maintained documentations, and it's just really difficult to find what are the actual assets, digital assets in the environment, and how you can identify those. And in my work, when we do a lot of cloud migration work, this is one of the first things that need to be done, basically like digital inventory catalog for all the assets in the environments. So at the same time, distributed systems have become like a mainstream architecture style, and it's always trade-off between development complexity and operational complexity, which means that now that we have these distributed small components, they are usually easier to deploy because unit of deployment is smaller than before, and they might be more reliable for the same reason. But then at the con side, the simplicity is lost. It's difficult to understand end-to-end streams between different components in the system. And my recommendation for these kind of environments is to use evolutionary architecture instead of creating upfront heavyweight enterprise architecture style. Just concentrate on these modularities and coupling between the components and how you organize things around business capabilities, really using domain-driven design principles that are widely used. And then through experimentation, you can sort of progress in your ecosystem and build it from the ground up. And really now I would say that the technology has changed a lot in the last few years, and we've seen these so-called seismic shifts in the industry, like Docker containers, Kubernetes, serverless computing. These are things that enable different kind of architecture styles, and that's one of the key drivers in a modern distributed architecture, as well as GitOps based workflows, infrastructure as a code, and even pipelines as a code, like how you orchestrate different things and how you orchestrate the whole environment, update components, and so forth. And the way I see discoverability, it's the quality of being able to find items in your environments, while observability is more like an offsite thing that you will observe the internal state of your systems. And in the core of this, I say that platform is really the enabling technology and platform thinking in a distributed system. And this is really what helps you to build these, let's say, like ITIL processes, infrastructure processes for the effective management and control of your system. So it includes service definitions, service relationships, configuration management, and overall discoverability of your asset data in the environment. In a way, I think discoverability belongs to the left side of the development life cycle, but of course it's also extensible, so it can be extended to business side and operation side of things as well. The challenge is really that when you do these at scale, for example, asset management, when you have hundreds of services, hundreds of different kind of components, usually asset management is done by Excel. There are other tools available as well, but the most common tool so far I've seen is just Excel sheet. And it's really difficult to keep things up to date with the pace of change required in our industry. Then infrastructure and pipeline codes. People are doing this quite a lot nowadays, but what I've seen many times that it suffers from the lack of the same quality as the application code, that it's done in a way that when your systems become more complex, it gets more and more difficult to maintain. And here I think really these core engineering practices like domain-driven design or test-driven development or continuous delivery, they can help a lot. And then abstractions that are often really low level, like when you think about infrastructure as code, tooling, and what's available, it's really the focus is on a resource level. It handles databases, compute, and buckets, and so forth. But this market architecture is missing from that picture. So there's no higher level abstraction that what's the business perspective of the systems architecture and what actually makes up a solution in your environment. And really, when you do this at scale, the way of working needs to be systemized so that there's a visibility across all teams. I really like this picture from Spotify about aligned autonomy, that you have these small teams, innovative organization, and those teams are highly aligned, but they are loosely coupled. So it's basically the same that we look for from the software architecture, that you have independent components. They are really loosely coupled with each other, but they are highly aligned, and they use same kind of principles and practices and ways of working. And this is really what we are after. So in overall, when I think about software architecture and the forces impacting the software architecture, there are a lot of different aspects. There's the logical level of the software architecture, like you have your infrastructure, you might have some foundational components like single sign-on and security and others. Then you have domain layers exposing the business capabilities in your organization, and then applications on top of that, which creates an ecosystem of different things. And there are a lot of driving forces in that model. There's a market architecture which always demands us to go faster. There's regulations, laws, and guidelines. And then there are different experiences. There's this consumer experience, operational experience, as well as usually partners and third parties, as well developers engaging in the same ecosystem. And from the architecture point of view, this is of course really challenging. And as an architect, you are usually expected to go all the way from the engine room to the to speak to the captains and talk about the same things about business terms, and then go back to the engine room and change those business rules and guidelines to software codes and architectures. And I think there are at least these guiding principles that I usually like to follow. The first one really is domain-driven design and the basics of domain-driven design. I will speak a little bit more about domain-driven design in a minute, but the next thing is platform thinking. So it's the capabilities that you have either to build or run applications. So it might mean components that you can reuse in your applications. So it can mean the whole environment, running environment like compute and foundational things. And usually the aim for platform is to reduce the variability in non-differentiating technologies. So things like Linux distros, you don't really want to concentrate on such things because that's not usually a direct business advantage in your domain. Then infrastructure as data. So I'll speak a little bit more detail about infrastructure as data, but in essence, what I mean about that is that there's two things basically. There's data and behavior, and actually the data, if you isolate the data, you can do a lot of interesting things with the data. And then there's discoverability and transparency. So when you have the data, just make it visible so that every team, every organization will be aligned and can act on the published data and services available in your platform. So the key thing in domain-driven design is models, and all models are always abstractions, and they usually serve some specific purpose. And maps are really commonly used for this illustration. So there's two maps on this side. The first one is the map that you would normally see, the projection, Mercator projection, that is used commonly for navigation. The problem with this map is that it inflates the size of objects that are away from the center line. So it's a distorted model for certain thing. And as an example, there's another way of drawing the same thing, drawing a model from the same thing. And I've chosen here to show Dumaxion map, which tries to preserve the shape and size, but now the model is really visually challenging over here. And they are clearly same underlying thing, but two different models. And now these models can be used for different purposes. And in a software, you usually see it in this way, that you might have a consumer model. And in this case, this is a GCP marketplace, which basically focus on discoverability and focus on searching all the assets that you can launch and install in your GCP account. And it's a created product list. There might be pricing information and other information included for that application. Then there's the developer model. So you can go to your project and you see the project level view. You can see API requests, and you can go and drill down to individual resource level. And at the same time, it's the same underlying thing. It's the same underlying application, but the models are completely different. And then again, from the ops side of things, it's again slightly different. It's usually consolidated, multiple applications, multiple models, and it concentrates on monitoring and resource usage, these errors, alertings, different environments, and so forth. So there are always many models in place. And then these models, when you start modeling your environment based on these different aspects, you kind of find out that infrastructure as a code is just a bunch of automated repeatable tasks and scripts to create and maintain the infrastructure. And it's usually very low on abstraction level. So you are talking about individual resources over there. And it's in a way, in many times it's the data and the behavior in the same package. And there are two ways of doing this. It's this YAML syntax, like declarative syntax, and then some of more like code SDK styles, like there's AWS CDK, there's Pulumi, which they do the same thing, but these two in the code. And of course, the difference here is that in the code you can do a lot of things. You can do looping, you can use variables and things like that. But in a templated model, you just basically create static templates. You can use variables, but that's about it. And then there's this data side of things, which are expressed in data structures. And I think we could actually design these things in terms of domain model, that instead of starting from infrastructure as code, I think we should start from infrastructure models and design the infrastructure. What things are important in our infrastructure in terms of domain models, and separate the data and the actual implementation logic. Because what it does is that it actually encapsulates the domain model in your infrastructure, and then feed that data into these infrastructure as code tools instead of bundling these together, because the same data, if it's in a format that can be consumed, it can be consumed in many different applications and in many different ways. And here's an example that we've used recently. Is we have a notion of application, which is really simple YAML format that tells a couple of things. It tells the name of the application. It tells the owner and a Git repo where the application is. There are some labels in place, and then it tells that there's an API which this application consumes, and some other data that we see that is important in this environment. For example, we list here that there's a dev environment, and this application should be deployed in a dev environment. Now, based on this data, we actually generated the Terraform data and template. And as you can see, these map to each other, but I believe the right side part is much more readable, and it actually gives more information about the actual application, what it does and what it exposes compared to this one. But the same thing in essence. And what we do with this data is that we create orchestration pipelines. So we have this data stored in a version control, and it's developed and used in the same set of practices as any other application code. So if someone wants to change the environment specification file, it will be done through pull request model. So compliance will be handled through pull requests in a GitLab. And it enforces a standardized deployment model for all processes, because all this environment orchestration happens through those environment files. And it's really extensible. So your model might look completely different than the model over here, but it's still the same thing. It's the idea is the same, that you have the data and your domain models, and then you can store it in a version control and then publish that model to different places. And In my demo, I will go through a little bit how it actually works and what are the components where we publish the data and what we do about it. But it's really about orchestration pipelines that we leverage what's already available in a GitLab. GitLab has a pretty good pipeline support, and we just use publishers to read the data and then feed different systems to set the states. And what's nice with this is that since it is always data, so you can do things like a developer portal fairly easily based on the same data as. Okay, and the next topic here is really that what enables this kind of environment, and it's really a platform as an internal product that when you model your environment, you are in essence creating a internal product platform, and there's usually two things in play here. It's economies of scale and cost of variance. And I mentioned earlier that the cost of variance is really in things that are non-differentiating in your environment. You don't really should have any variability because that's just heavy lifting. And then in a distributed environment, when you have a lot of different things in play, you want to standardize things in order to be more aligned. And that's about platform. And platform always requires a product mindset, although you never probably expose the platform as is outside of your organization, but it's still a product, internal product in your organization, and your developers and other people involved in the process, they are your customers. And it usually requires technology normalization because it's just with a large scale of number of technologies, it just becomes really difficult to maintain. But it really comes down to a few different things. You have capabilities, and it should be really easy to discover all the capabilities in the environment. The onboarding, when you get a lot of new developers, it should be self-service. And understanding is really important. So it needs to be easily understandable without any extensive documentation. And if you need documentation, it needs to be put in a place that it's easily accessible. And platform should be always easier to consume than building the same thing on your own, because if the bar is really high, then the developers and others won't really use your platform. So easy to use is the key. And let's go and jump into the fun part, which is the code part. So how we have done this in the past is in a few projects that we've started building different things. My environment here is a little bit GCP focused, but we have modeled a really sample environment that we have an aspect of different environments, dev, prod, QA, and sandbox environment. And then inside each environment, we have some folders, and we have a root organization, and then we have some projects. In AWS, these projects would be the same thing as account in AWS. So project is a way to isolate workloads in GCP in the same manner as account in AWS. And then finally, we have modeled some APIs and some applications. And the idea is really simple. We have some teams creating services, domain services in the organization. So they are actually based on these YAML files, they are able to tell to the organization that, hey, we have this new business capability, which in this case is called a pet store API, that this is now available, come and use it. There's another one which is weather forecast API. And it's the same idea. It says that there's an API spec available. There's some information about the parts, some labels, and then this tells that this one is exposed in the dev environment. And also on a project level, we tell that which things are included in which project. And the nice thing with this structure is that all of this information over here is just data. And with this data, we have done this really simple node-based application that just has different publishers built in. We use Apache as our API gateway product at Nortal. So we publish all APIs in our Apache instance. Then we have a simplest publisher that could possibly work. It just writes down the or prints std out for all the things that it's loaded, and then we generate Terraform. We create secrets in GCP, and that's about it. And all this actually works based on npm scripts. So there's a command line for each of these different tasks in the application. So I can do npm run publish std out, and I should be able to get the organizations and environments in my environment. I can do npm run publish Terraform, and this will create, let's do this one. Let's delete the folder where I have the okay, let's do this in a here. Okay, it's there now, loading the things and creating the Terraform script. But what comes out of it is really that. Let's go to our GitLab account over here. And now that we have the data in a place, we built a pipeline in a GitLab. That basically the first thing to do is just unit test all the code, all the publishers, test load the content we have and make sure that everything is valid. Then build a node container and then do some publishing. So this one here creates Terraform plan And now all this code over here is just generated from the YAML files. And then in the end, it says here that 3 to add to the change, 0 to destroy. And then the final stage in this job, let's go over there. Again, over here. Let's look at the pipeline. And now I have here Terraform apply as a manual action. So we can use this pipeline as a remote control for our GCP environment. And now if everything is okay, someone can go over here and apply this configuration to our GCP account. And you can apply the same principle in your pipelines for some other services as well. So what I've seen, for example, a common one is to restart a Kubernetes pod when you have configuration changes in place. So that's how those pipelines work in a GitLab, and it's fairly easy to do with these npm-based tasks because it basically gives you all the things how you can configure things and how you can build different commands and publishers. The actual code is really simple. We just go through all registered publishers, which is a list over here, and then inject this data. What is our domain model into each publisher, and they do different things with that. So as an example, I could show you, let's do a secret. So I have project, and in my projects, hold on, the mouse is a little bit laggy. Let's go over here. So I have a project over here, and I want to do my configuration. Let's say this is called my configuration, and there's a thing called value which says hello. Not wanna put that in a quotes. And then I run np run publish secrets. So this would be executed inside the GitLab pipeline, and it would create the secret. And now if I takes a while, then it actually goes through. And now if I go to my project over here, I think it was this one. And it was called my configuration. Let's see if I'm in the right place. So usually this is a little bit asynchronous, so not necessarily see it immediately. Let's see. Should say that it's here. Update it, and it's this project, and it's this one. So basically what I did is I published a configuration over here, and if we look at this configuration, we should be able to see the value, the secret value, hello over here. And now you have end-to-end pipeline to actually store secrets in your system. So the last thing I want to show you is that since this everything over here is just YAML files, and you've already seen how easy it was to read with the JavaScript. I have an content management system called Gatsby over here, and we link the same data with Gatsby. So there's a GraphQL interface for all the data we have in those YAML files. So you can basically do different queries based on that data. So there's an API available. And since there's an API available, it's really easy to do these developer portals and different portals based on the data and really show how your environment looks like. And for example, here, this view is just generated basically from the same YAML using those GraphQL interfaces. And under the hood, Gatsby is just a standard React thing. So nothing too exotic, really easy to get going. And you can use your standard React components that you might use in your business apps as well. And then you have a single place to do different things, like here's the health check. It says that the underlying service is healthy. And it's all just based on the same YAML file that we have. All right, back to the slides. So this is the demonstration part that I showed you. Once we hand over the slides, you can see the same things a little bit more detailed. There's Apache part in this as well. But maybe a couple of things where to go next. I'm really keen to look into different things here. I really want to try out a tool called backstage.io, which I have here open, which is a developer portal done by Spotify, which has really nice plugin model. So I want to see whether I can embed the same data into this Backstage and start using this for certain things. Also, our YAML file looks a little bit exotic, and I'm planning to try to use those Kubernetes resource definitions, because basically you could do the same in Kubernetes as well and have custom resource definitions like GCP config connector is doing today. And that might be a really good option for environments that are using Kubernetes, but I'll need to look into that a little bit more detail. So putting it all together, a couple of key takeaways really. These distributed systems are really difficult to do. Like, if you don't have the operational capabilities to do distributed systems, I think in many cases, like good monolith layered architecture is still, in many ways, it's easier to do and easier to manage if you don't have the operational capabilities in place. And these infrastructure codes are still fairly low level, but if you think about this configuration, like YAML-based declarative configuration, I think we are going to see a next generation of infrastructure orchestration tooling. And my expectation really is that this will take off, and I believe that tooling will be much better in a few years, and these concepts like APIs and services and others will be in those as well. Then, since all the infrastructure code is just code, so I believe that that code, you should apply the same design principles and engineering practices like solid principles, separating the data from behavior, as you would do with any other code, your application code as well. And always set closing word, like start from something really simple. Don't try to over-engineer your system. And it's always much easier to start from a small and then incrementally make up your system instead of start from a complex system from scratch. Yeah, that's the presentation part. Then any questions so far?
Thank you, Aki. That was a great talk. We do have some questions also, and I actually have a few questions of my own. So I'll go through all of the questions. If the listeners have any more questions at this point, then feel free to ask them. This is your one and only chance for the next 10 minutes.
Yeah, well, you can always email me or call me or get connected with LinkedIn. So plenty of opportunity to ask this later as well.
So I'll go through them. The first question is, if there is one principle everybody could follow without early or over engineering, what would it be?
Yeah, I would think start from simple. That's the way forward. What I've used in the past is that when I do an application, I've sometimes started from index HTML page, get the deployment pipeline for that index HTML page, and get going from that. So start simple.
Great. Another question is, how would you recommend setting up a platform process?
So I would think platform process always needs some sort of platform team that will work with other teams. And there are two ways of doing that. Some people prefer foundational platforms that are usually built based on some requirements, and some people prefer harvested frameworks, which is basically build something for now and then refactor those once you build and you start seeing more commonalities between different things. And I think I prefer that option as well, that start from what you need now and then start thinking the platform when you have enough common applications to actually justify the platform.
All right, and another question is, when do you decide to build your own tools versus using OSS tools?
So I always prefer using tools that are ready-made and built, and I prefer, like, I don't recommend, for example, building your own customized Terraform or customized CloudFormation. Use those tools that are available for you, but then when you see that there are things that the tools won't support, maybe that's the time that you extend the architecture somehow and build those capabilities on top of the existing tools. But there's no really point of replacing those existing tools because they are usually very well made and they serve the purpose.
Okay. I actually did have a few questions also. One of my questions is that obviously using this sort of approach is very beneficial. How hard do you think it is if you already have an existing infrastructure? How hard is it to migrate to the infrastructure as data approach, and when should organizations be thinking about that?
So I've been helping quite many organizations to migrate things to the cloud, and that's usually the natural place to start thinking things differently. That when you are doing these migration projects, you need to do the inventory management anyway, and that's maybe the right place to actually do something better and fix the existing problem, because that's the work you need to do anyway. So why not formalize that work and do it properly?